is COP326, Elevating Application and Generative AI Observability. My name is Matheus Arraes. I'm a worldwide tech lead for CloudOps, based out of Dallas, Texas. This is my sixth reInvent. I'm very excited to be here. I have Peter with me.
Hi, I'm Peter Gang. I'm a product manager in CloudWatch. My first reInvent, but very excited to meet you as well.
Awesome. So let's start with this picture. So imagine if you were in a store, like if you're driving down an unfamiliar highway and you have very limited visibility. So it's quite nervous-wracking and dangerous as well. You don't know exactly what's the road's gonna do or what's gonna appear in front of you. And you're just starting to grip the steering wheel within hotter. Your palms are sweating. You just wanna make sure they'll drive safe home. We all be in this, this familiar situation, driving with limited visibility, and we don't wish it to repeat it again. So this is like operating in today's complex applications powered by AI. We often lack of visibility and observability, and you just wanted to understand how the systems are driving forward. And without it, it's quite dangerous. Even our CTO, Werner Voges, he once said that you needed to have a visibility because without it, you're just guessing. You're guessing what the system's going to do next, how the systems will react to the dynamics of your end users. So in this presentation, we're going to help with that. First of all, I'm going to understand how application observability monitoring is today. What are the challenges that you have now that we have generative AI in place, and how that comes and play along with that. How to gain visibility and observability to AI-powered applications. So our commitment, myself and Peter, that you're going to walk through this session, going back to your places, your homes, with actionable insights for how you elevate application, but also generative AI observability in a single pane of glass. Let's start with John. So John here is our persona. So he's an SRE, he's a developer, he's someone that is using CloudWatch on a daily basis. And as you can see, his application right there is quite complex. There is many layers. There's backend, database, infrastructure layer. So John's using just the simple monitoring, like CPU, metric, stuff like that. There is many layers on that application that John can leverage, as you can see on this diagram. So each layer that you see on the screen is a possible layer that it can be observed. So networking, infrastructure, application, database, users, and so on. From the bottom up, AWS offers many choices for you, for instance, on the infrastructure. So you can observe on the ECU perspective, containers perspective, serverless, on-premise, and so on. Application layer, which is one of the crucial ones, because you can use application logs to understand how the application traces the interconnection between your applications, moving from the CPU metric perspective to a service level objective perspective, time-backed to your business outcome. Last but not least, you have the user perspective, where you can create understanding of your user behavior and using CloudWatch for that. So what John have asked for us, it is, I wanted a native integration because he's using AWS today. He wanted faster time to detect problems and also to resolve them. He wanted to cost optimize. Doesn't want to move data from here to there. Doing deduplication is quite complex. And also, it should be a single pane of glass. It should be a simple service to use that has actionable insight. It is smart. It's using, for instance, machine learning to understand anomaly. And for each one of those layers, Amazon CloudWatch offers John a perspective and an option to monitor his application cover to cover. So from the bottom up, in the internet, in network perspective, we have, for instance, internet monitoring. can analyze internet performance, understanding if it is also your provider, internet provider has problems, some outages. You have the infrastructure level, the blue one, where you can have CPU, container, servers, on-premise, and you can leverage containers insights, Lambdas insights to understand the system level of that particular infrastructure choice. We have database insights too, to collect, monitor database performance in the real time, so you can leverage, understand which SQL queries is taking longer than others. The green one, which is the application level, is the most crucial one, like I said before, because you can automatically detect your KPIs, your application KPIs, and use SLOs to maintain server quality commitments that you have with your customers. Last but not least, the top level, which is the user perspective, you can use real user monitoring, and synthetics to produce canaries, to simulate what the user's behavior in an alert if you have any availability issues or performance degradation. All of that in a single tool, which is Amazon CloudWatch. So going to the 3 pillars of observability, everyone might be familiar with this, but that's the journey that we wanted to discuss here. Every monitorability strategy will come along with metrics, logs, and traces. This is called as the three pillars of observability. Metrics, it is, I wanted to understand, I have the information that my application response latency increased 35%. Logs, I have the information in a data structure, or not a structure, that my authentication, user just authentication in my application. And trace, I can ask questions or answer questions about distribution processing time of my microservice across the board. So as you saw it in the beginning, John has a quite complex architecture, and then of course some challenge also arise with that. Microservice, like a complex architecture, needs constantly performance over time to satisfy the end user. You have also, John needs to manually stitch together telemetry data with the service to understand the degradation of availability and high latency. Also, it's very hard to understand what is the priority for the business. Right? Understand those anomalies, which ones matter most to the business, and how he should prioritize with that. Last but not least, disjoint experience, because correlating that telemetry data from the perspective of metrics, logs, and traces, you also needed to put in place real user monitoring, synthetics monitoring. If you put that all together, that can extend it in a very long time to detect the real issue. Now, in order to offer a technical perspective, how John should use and what he should use, and look specifically for elevate his monitoring, it is the golden signals. So the golden signals are volume requests, which is directly impact the demanding place of your application, directly impacts also in latency. Latency is speed, right? How much time a specific request will expand to be resolved. And for that, if you have high latency, you also have the directly impacting the user's experience. The two in the bottles, you have fault and errors. This is a tie back to requests. There are malform or application issues. So you needed to understand those in order to understand your application monitor as another level. Now, this is a technical perspective. What John needed to do here, it is also to connect that from the business perspective, right? So, for instance, business impacts directly to revenue per minute, or car, if you have a car abdomen. What is the level of that? What is the user experience signal? For instance, page load time. What is the API errors code and session duration, so on and so forth. You have service health indicators like latency, P90, P95. You wanted to understand that particular piece to understand the overall health. And last but not least, connecting with reliability objectives, tying back each signal with an SLO, a service level object, to ensure that you're maintaining the optimal level of the application. So in order to answer those questions, John should focus on that particular layer, because on that layer, it's where John can tie back all those nodes, all those dots, the application level. And Amazon offer an APM solution called Amazon CloudWatch Application Signals. From using application signals, John can elevate his application monitoring because, first of all, that is, application signals automatically discover which applications you have in your account. Using OpenTelemetry SDK, you don't need it to do anything, right? It's already automatically discovered for you by CloudWatch. Second of all, there is pre-built dashboards that will standard metrics, including those golden signals, will have that so we can understand that technical metrics that I just mentioned a few seconds ago. Third, you have easy understanding with a few clicks, the root cause if you have a HTTP malform, if you have an exception, you can understand where this was the exception, which line of code, and so on. Last but not least, SLO, Service Link Object. So this is related to goals on your reliability and tying back to the business objectives. This is crucial for any application monitoring strategy. And that's why when we talk about application monitoring, we talk about SLOs, because it is a comprehensive understanding of application health from the user perspective. And this is how it works. You have an application or an API called Get Research API. And I have a particular internal goal of 99.9% of uptime of this particular API. Well, in order to have that, I already select a particular SLI, which is Service Link Indicator, to measure that goal. In this case, it is uptime. But as you see, there is a 0.1% that can create something called error budget, which means if I'm evaluating this particular SLO in a 30 days period, I still have 43 minutes of downtime and still meet my SLO. Why is this important? Because you can tie all this back with your SLA. And SLA, everyone knows, is an agreement that you do with your customers. So when you put it in the perspective, what are you going to have? You're going to have happy customers, because if you are looking for all those APIs, establishing all those SLOs, tying back to the SLIs, customers are able to understand that you take care of your application. In this particular case, John will achieve happy users too. Okay, so let's go for the demo. Let's go to the fun part. In this demo, I'm going to show specifically two scenarios of fault and also latency problems that I have in my application, and how we can use application signals to monitor my entire application observability in a single console. So first of all, what I'm going to do is to show SLOs. So I have multiple SLOs, as you can see here, and some of them, of course, are unhealthy. I wanted to show how to create an SLO. SLO can be, I needed to choose first the SLI. SLI can be a service operation, a CloudWatch metric, or a service dependency. And again, that service means that it's automatically discovered by OpenTelemetry SDK. In this case, I'm going to use my front end, Pat Clinic front end, and a specific operation of posts. And the interesting part right now, I can select the calculation method for this particular SLO, which can be by request or by period. And I can select also the condition of that particular calculation method that can be either by latency, I'm choosing 100 milliseconds right now, and or also availability. One of the cool things, it is CloudWatch put that little phrase over there, which is exactly determines what I'm doing, in that configuration. From that, I select what is my SLO. I define my interval of period that will be assessed by this SLO, the attainment goal, and also I have that little phrase over there. Of course, none of this makes sense if I don't tie back alarms. Alarms can be directly related to the SLI or the SLO attainment goal and the overall health of this SLO. Everything there, it makes sense for that particular API. Now, I wanted to show also something beyond it, which is application map. We launched this like a couple of weeks ago. This is the what I mentioned related to auto discovery from the OpenTelemetry perspective. Not just instrumented, but also uninstrumented application are capable to be discovered by application map. I can filter by groups. There's multiple filters that I can select over here, and then all the applications that I have in this account will automatically be select on those little boxes on the right-hand side. Even if I wanted to create my own custom attribute, I can use configurations directly on OpenTelemetry config file, and will show up directly here on the console too. Now, going a little bit deeper on the path clinic that I mentioned, when I double click, I see the whole topology. So this is my whole topology for my application. All the connections that I have with the front end, with the back end, all the microservice that I have connections, I can see. And if I click on the thin line, I'm able to see the interconnection between one server to the other and understand the top path with fault rate, with high latency, so on and so forth. If I click in that particular front end back again, what I have on the right-hand side, it is the golden signals that I mentioned before. So request, volume request, latency, errors, and faults are out of the gate for me over there. I can enlarge to see this over the time and select P90, P99, or P50. And one of the cool things that I believe here that CloudWatch gives it is this operational auditing. So as you can see, I have some drops, some spikes. So CloudWatch already given to me over there what the indication that the problem should be. So what exactly happened in that period of time, and what's going to happen, you needed to assess even further. So to assess even further, when I click in the dashboard, I can see the overall metrics for this particular application. And again, metrics, all the golden signals are here, as you can see. But one of the things that I mentioned in the SLO creation, it is the service operation. So using OpenTelemetry, I'm able to understand all the posts, the gets, the puts that this application is using behind the scenes, and understand, as you can see, I have SLIs that are unhealthy. If I double click in the dashboard, because I have a spike of a fault, it will automatically show the correlation of spans that it's necessary for that request to be served. And if I click in one of those spans, it will show me exactly what is the tracing map from the front end to the back end, what exactly the whole trace and the spans for this request to be resolved. And I can even see the same visualization, but now in a timeline perspective, in a span timeline perspective, where is this host? And as you can see, there is a fault in the visit service Java is throwing an exception. And the exception, it is a DynamoDB throughput problem. I can see the message and also the line, specifically the line that in my code I needed to go back and fix the problem. And even in the DynamoDB's perspective, I can see the message on the right-hand side too. one of the interesting part, if I go back to the previous dashboard, I can also see, because this is an EKS cluster, where is the node that is having most problems with this particular fault, and what exactly are the pods that are having this pod, and then I can prioritize by looking to these nodes and pods. Even if I click to Container Insights on this little button, is going to guide me to a console where I can see my Container Insights performance across the board. This is in the single pane of glass. So dependencies is another tab on again, same application, that I can see all the dependencies related to this application. And also, of course, the dependency related to the service. So this is the second use case that I talk about latency. So as you can see, there is a spike in this specific time, and I'm just going to click on one of the traces using the same methodology on the previous use case, but now looking for latency. And you're going to see that now, because it's a different API that I have high latency, it's being served for different service, including, for instance, Bedrock. I have the same visualization, trace map, and also the timeline with all the spans. And as you can see, the Bedrock runtime has an arrow specifically. When I click into view, it will show me exactly what the section is being thrown in my code. In this case, the problem is the Bedrock foundation model is being deprecated. So that's why I have high latency, because it's been deprecated, so it's taking too much time to be resolved back to my user. And even if I click in the event, I will be able to see that more properly. Now, this is the application level. I wanted to also show the user, that top level layer. You can use synthetic canaries to create and simulate users' behavior. In this case, of our persona John, you can create to simulate what exactly steps that needs to be used and simulate what a user will use his applications for. And we'll take little screenshots as well if you determine to do so. You can also use the user experience, the run that I mentioned before, to understand page load. If there are any errors, you can see when I increase the time on the right-hand side, I can see the errors over time, understand what exactly the page that I have from the user perspective that are having the problems with load specifically. And when I click one of these, that's giving me the entire information regarding that particular error. And this is a user perspective. So I can see when the session happened, when it is happening, which type of browser CloudWatch used to simulate the user behavior, and I can understand my user experience across the board. Now, this is the application part. And now I wanted to move over to the Gen AI, because now John Peter needs to include Gen AI in his application.
Thank you so much, Matthias. I'm so excited here to talk to you about how observability has changed to monitor AI workloads. So raise your hand if you are currently building an AI application or workload in your company. Okay, wow, most of the room. So you're in the right place. So looking back this crazy year, this 2025, we all know that AI-powered applications is going to transform the way that your business and your users interact with your business. Every tech leader here is seeing in real time how easy and powerful it is to build these AI workloads on AWS. So I'm here to help you navigate through this time in a lens from observability and showing you three things. Number one, how observability has changed and the new tools that you can use. And second, how observability is still some of the same things that you're already familiar with, and show you the existing tools that you can use. And lastly, showing you all that together with a demo of that workload. So walking back in memory lane, so we started this AI talk back when we had these question and answer chatbots, but that is still 2023. What we then had, these are AI assistants, or kind of the AI entity that walks the user step by step through a particular business process. But now today, what we have is AI agents These entities are more autonomous that can do certain tasks by themselves and make decisions independently to achieve specific goals. What we think in the future will be is fully agentic systems, where the entire systems behave independently, achieve open-ended requests and goals, and help the entire business make its own decision and drive those outcomes. And how do you even build these AI applications? In AWS, we offer a full stack of tools for you to build those workloads, and monitoring is across the entire stack. Starting from the bottom, it can help you build, run, train, and deploy those AI models on SageMaker and also on our infrastructure. And the middle layer, I think, is going to be the meat of it. It's going to be first is the Amazon Bedrock, which is a fully managed service that offers you direct access to a slew of foundation models through a single API, so you can scale up your application really easily. And then the more recently launched Agent Core, which is the place for you to build and deploy highly scalable and capable AI agents. It comes with a suite of tools to augment those agents with memory, so the agent knows the context, with gateway, so the agent has control over what kind of third-party APIs it calls, and identity for authentication and control. And going higher, even in AWS, we've used these things to build up those fully agentic systems with Kuro, the agentic IDE, Q, agentic business intelligence, and also Amazon Connect, which is agentic contact center. They've been loved by millions of customers. So wherever, however you're building AI, we've got you covered. And again, in every layer, observability is there with you. Now, here comes the question is, how do you have the right observability on these AI applications? How do you see, how do you track what the AI is doing? And then what's new, what's different? So let me help you navigate through this rapidly changing time. With these AI applications, what we've talked to customers, and they've unanimously come back to us with some common challenges. Number one, these agents can be indeterministic. Their actions can differ from time to time, even from similar past scenarios. It's very unexpected. They're like teenagers. Sometimes they say brilliant things. Sometimes you wish they didn't say anything at all. And second, root cause analysis is focused on tracking the sequence of calls that the agents made, but it's very difficult to trace. Analyzing those invocations at scale is very difficult because every model provider has a slightly different format, and tracking that volume across different regions and accounts is harder than it's supposed to be. Now, and also lastly is assessing system health. It's still the same goal that Matthias talked about, but what's new is this word quality, right? Now you need to answer why did the agent do the thing it did? Why did it route itself in that way? What context did it have? Well, sort of the traditional monitoring tools can tell you the performance, surface layer performance parameters, like latency errors, but it doesn't tell you that the reasoning, doesn't explain to you the AI decision-making process. So you are no longer just observing whether your AI is working or not, going up or down, but you're trying to observe reasoning and intent. And we believe this will be your new operational reality. Observability is going to be the control plane for trust, safety, and quality. Now, going back to the same stack layer that Matthias showed you, we believe that AI workload is going to ride on top of all of this. And observability is there is going to be operate at the highest level with you as well, connecting from all the way from the infrastructure signals, stitching the telemetry throughout the stack, and coalescing from those different models, agent actions to observe the entire end-to-end interaction for you. That's why from those challenges, we worked backwards to introduce to you Amazon GenAI Observability, already in GA. Has a slew of capabilities. Number one is a 360-degree view of your agent, no matter what model they're using, on frameworks such as Strands, Crew AI, LangChain, and with out-of-the-box dashboards on those performance parameters. Second, it's very simple to instrument your AI workload, as long as using OTel, which is open telemetry format. We'll touch on that a little bit later. And very importantly is the end-to-end prompt tracing, which traces across the LLM calls, the agent actions, the tools, the memory calls that makes for you to quickly identify issues. And in the data protection world, now in these AI interactions, it's very likely that what the AI receives or the AI outputs can contain PII content. And those are stored in the logs, and we have data protection features to mask that content and protect it. And lastly is the evaluations feature for you to monitor the quality. And these are using LLM as a judge to constantly assess how your AI is responding, whether it's saying the right things, whether it's routing itself correctly and solving your customer problems. And to build these agents is fairly easy on AWS Agent Core. Agent Core allows you to deploy, operate highly capable AI agents securely at scale. It offers infrastructure purpose-built for these dynamic agent workloads. As you can tell, it coalesces from different aspects of what the agent would use. For example, any model, LM model offered on Bedrock, and it will use Agent Core memory, which is the context it pulls and uses to operate. Identity looks at controls the security, and also gateway, which is a central place for it to make third-party API tool calls and all of that. And as you can see, all of the tools and the primitives around the agent send telemetry to the observability platform, which is CloudWatch GenAI Observability. So you can have that single pane of glass to monitor all of this. One thing I do want to highlight has been resonating with a lot of our customers is that you can host your agent on Agent Core runtime service, and that telemetry comes through CloudWatch. You can get all the features I talked about out of the box. Also, if you're hosting your agents elsewhere, EC2, AKS, on-prem, or other clouds, as long as your data is in the OLTEL format, we can also accept it, and you'll get very similar capabilities in CloudWatch as well. So giving you that flexibility wherever fits your needs. Going into a little bit deeper on the agents running in Agent Core runtime. When creating and running these agents, we provide even more flexibility on how you create them. We support agentic frameworks like very popular ones, Strands agents, Crew AI, LangChain, and the instrumentation. Supported instrumentation libraries are very broad, are all open source, open inference, trace loop. And once you've been instrumented, connected with the Amazon distro for OpenTelemetry, ADOT, and we collect that instrumentation, send it to the CloudWatch OLTEL endpoint, and we'll be powering those screens I talked about before. Or specifically, agents hosted on runtime. Remember that ADOT I talked about? Plus, once all of that telemetry is coming in the CloudWatch telemetry config, with a single click, you can turn on all of the telemetry from those individual primitives, like Agent Core memory, Agent Core gateway, in a single click from the entire account, all of that comes to CloudWatch and power those views. And for agents hosted elsewhere, still the ADOT, but I need to emphasize that as long as in the OLTEL format, we also accept it and turn on CloudWatch transaction search to stitch together those actions and tool calls that talked about in there. And here's a very, very easy quick start guide. You can even start it working on it right now on your laptop. So with all that groundwork we laid, let's focus on what John is doing with his GenAI workloads in more practical terms. Here, I think this slide looks very similar to you of what you saw before. And you already know it. It's the metrics, the logs, and the traces. And that's still powering the GenAI observability. That's the same old tools you're using today. So with metrics, these things are like the token consumption. And you're tracking how those have changed, the volume of work the AI has done. Well, the logs is where you keep those verbose inputs and outputs from the user and from the outputs of the LM models and the agents. And lastly, tracing, very important. The traces now can understand how the response propagates through the entire system, and you can analyze it at the aggregate level, and you have the capability to drill down on every single interaction. Okay, a little bit more detail on how it really works. Metrics, these are some common metrics you'll be able to monitor on is number of invocations, how fast these invocations are completing itself, any throttles, and the volume work, like inputs, token counts, output token counts, and the logs coming from the model invocation logging, and also the span logs, which contain each individual step and the contents of any tool calls and agent actions. And lastly, the trace, as long as it contains the same session ID or trace ID, and stitched together, we'll be able to surface those the end-to-end interaction that I talked to you about before. And with those, on the metrics, we've put it into the same set of golden metrics that we believe you should be monitoring. And the first bucket is the token usage, the volume of work that the AI is doing, and help you to not only forecast the demand that you will have, and also cost. And then latency, how fast is your AI responding to your needs? Throttles, to keep a track about how close you're going against your limits and quotas, and errors, seeing anything that's going wrong in your request. And we'll be able to surface all of these things in a pre-built automatic dashboards without any configuration, so you can diagnose, troubleshoot from here. Additional filters include filtering by the model itself, so you can deep down into any specific model you're using, anything going wrong there. And also is definitely fully integrated with existing CloudWatch capabilities, like alerting, if you wanted to keep track of your total consumption patterns. Now, here's something that's going to be very different. It's relatively new concept to the world of observability that's relevant in AI. Now, like I said before, the new operational reality for you is going to be looking at the quality of those AI responses and agent actions. So often these LLMs hallucinate, or the agents take on a path all of its own that's not desired. And in the past, how teams have kept an eye on these qualitative issues, is the science teams take a very small sample of the AI workloads, manually look at it and assess it, and only when that's good, they're just okay with deploying the AI out in the real world, almost hesitating and timid about what it's really going to do. So there's lack of trust, and also very burdensome in the entire process. So that's why with evaluations, you can leverage LLM as a judge to assess how faithful an agent is saying, adhering to its context, how well it follows the instructions you've given it, and how helpful it was in helping your customers achieve their tasks and questions. And this is done continuously, automatically, on the entire traffic of your AI workload. And you have the ability to sample on full sampling or only a proportion of the samples. So really removes the labor-intensive and manual assessment process that our customer teams used to do. So evaluations metrics was just launched yesterday and is available now in CloudWatch, powered by Agent Core evaluations. We talked about the metric side of things. Coming back into the logs, some of my favorite, because this is the most densely packed information that you'll be using. I'm going to be talking about the invocation logs, how to query on them, and protecting that data. So the invocation logs can come from both the LLM model itself and also the agents. You can choose to come to a CloudWatch or S3. And once it's in CloudWatch, it's stored in the familiar CloudWatch log groups concept that you can use integrate with your existing workflows. And once those logs are in CloudWatch, you can use the CloudWatch log insights to drill down deeper, which is a powerful querying tool. We support powerful languages like SQL, OpenSearch PPL, and launching powerful query commands regularly. And you can use pattern analysis to detect common text structures within the log events for faster insights, and also automated real-time anomaly detection to identify changes in these agent behaviors and performance changes. And then I said before, these customer interactions can contain PII information, and we've got you covered when those logs are in CloudWatch. The CloudWatch data protection feature can identify and mask sensitive customer information like credit cards, names, addresses, and basically redact it for you. Also, we offer granular IAM role-based controls so that if a super user needs to see the content, they can, but most users won't be able to. And we generate automatic audit reports for compliance and reporting. Now, coming back to the last part, we talked about metrics, we talked about logs, and we're talking about traces now. This is probably the most important part in the GenAI observability. With tracing, the first thing we'll be able to do for you is show you the detailed information of every single individual API call and the function calls that agents made in a very neat list view. You no longer need to query on them on multiple databases to stitch them together. It's done for you. And second, we'll show you those actions in a timeline view so you can know, hey, which one's taking the longest, which one's taking longer than I expect for you to troubleshoot faster, and a trajectory map showing you all those different interactions, API calls, tool calls for this particular trace. And each step here is a span and aggregated to this trace. This map is automatically visualized for you, so you can easily understand the hierarchy and the sequence of those tool calls in a very easy to understand fashion. Now, I talked about what's different, what's the same, the logs, metrics, and traces. So there's a lot. Let's tie it all back together with a short demo.
Okay, let's go to the demo part then. So in this demo, now we're gonna see kind of the path clinic that I showed before, but now in the GenAI observability use case. And this is a perspective of an administrator or a manager that is using a fully chat hosted in an agent that is hosted by Agent Core. And then behind the scenes, that is multiple microservices that you saw that before. This is the same old joint application. So you have database and so on and so forth. So here, I'm just typing a couple of prompts related to this path clinic. And this particular prompt here, it is showing me like informations related to the owner ID. As you can see, there will be some PII information as Peter before. This is, of course, an agent that's being used for an administrator perspective. And in this last prompt, it is related to billing information for this path ID number 1. And what you're going to see is the agent will not be able to capture that information, to fetch that information for some reasons. Now, this is, of course, it is the front end. Let's go and actually see in the console. So first of all, in the left-hand side on Amazon CloudWatch, you're going to see a new section called GenAI Observability. And this is the model invocation that Peter showed before. You have that golden signals, the GenAI golden signals for invocation, latency, and so on. And all the invocations that you have in the foundation model, you'll be able to either filter, query them in CloudWatch logs inside, and also see the whole JSON file. You can even filter by model IDs that probably are using multiple different foundation models that you can also see. Now, going to the Bedrock Agent Core, not just for the runtime, but CloudWatch also observe other parts of Agent Core too. So memory, gate, and so on. Here, focus on the agent runtime specifically. I have 3 agents. I see all the overall information regarding these agents, how many sessions, how many traces. Going deeper in the path clinic, because it's the one that I'm using, I wanted to show a couple of informations here. In this overview tab, I have out of the gate information related to the evaluation. So I'm using evaluations, and I can see the evaluations score and also configuration metric. I can see the error in latency by span specifically, and I have this table. As you can see, there's many errors related to the DynamoDB, and I can see that information, of course, double click it if I need it. Scrolling a little bit down, still on the overview page, I see how many sessions this agent had, how many traces, and also token consumption, very important for cost optimization and how AWS charge you. It's information that is useful. how many sessions the time has, and the latency. Everything that you're seeing, it is already pre-built for you. Last but not least was the CPU and memory utilization. Now, each interaction with the agent, it creates sessions, and sessions contain traces, and traces contain spans. So going deeper on the session part, I just reduced the time for 5 minutes, so captured the last prompts that I did. And what I can see, it is kind of the same information that I had, but now looking for just for this particular session. So it allows you to go deeper on this particular prompt. If I click on one of those traces, what I can see out of the gate, it is how many spans, latency, token consumption. If I have any errors, I already see one of the errors. Remember that I was not able to fetch that data. I also see the trajectory of this whole prompt, cover to cover, what exactly the agent had to do in order to produce the information back, and all the tools that the agent have to call in my behalf. I able to see also the spans in the format of a timeline tree, and also in the timeline. Here I'm showing the token consumption on that particular invocation, input and output. And this is the same visualization, but now in a timeline perspective. So as you can see, I have multiple ways to understand how this particular session is doing. Looking for the event itself, here is where I will be able to see the prompt that I did, right? It is trying to get information regarding payment, and then a tool internally will be a trigger. And then what is going to happen, because that information is in a DynamoDB table, the agent doesn't have permission. So it is throwing an exception, access deny exception over there, because the agent itself doesn't have a permission to fetch that information. That's why I was not able to see that information on the agent. So here, in order to fix it, I needed to, of course, go in the IAM role of the agent and give it a permission to do so. Now, I wanted to show, because we mentioned related to evaluations, right? I have a LLM as a judge in front of this particular agent, and I'm just going to change the time here to 12 hours to cover how many sampling information was used to analyze by this LLM. And first of all, I can see the evaluation configuration across the board. So filtering it is available, and I can see like related to stereotyping, to session, and so on and so forth. So each the evaluation is offered that same granularity, session, trace, and spans too. So as you can see, all the tracings that I have in this particular agent, it is right there, and I can filter by many options that is being used by the evaluator. I also have the dashboards, right? Building dashboards created by CloudWatch. So each one of those elements, those metrics that is being used by the evaluator, it is right here. So instruction follow. If the LLM used the instruction that I gave, if it's harmful, if it is helpful, if it is stereotyping, all that information, it is right here, so I can understand the agent behavior itself. And of course, I have that as in a log format to using CloudWatch logs. I just want to go back to the demo and to the session specifically to show one last case, one last use case, going back to the same session, but now one of the prompts that I did, if you remember, was related to getting information for a specific owner. And again, I'm gonna have all the information related to the trace. But I wanted to show, because I have data protection rule in place for my CloudWatch, and that specific rule is masking birth dates and also telephone numbers. As you can see, it will be masked in the logs too, right? Directly here on the console. So we're closing to our session today. So I wanted to make sure you leave with a few takeaways. So first of all, getting started today, enhancing like your observability stack. As you saw in the first demo and also in the first part, we talk about application monitoring. You can use APM to help you enhance your overall application, understanding more the interconnection, the dependencies that you have in the application. You can use an application map, for instance, to see the topology of your application. It is automatically discovered using OpenTelemetry. Second of all, you are building agents. You should build agents and use CloudWatch GenAI observability to overall understand and observe your agents. If they are hosted by Agent Core or not, you can still use CloudWatch GenAI observability and fully integrate it with Amazon CloudWatch. And use the assessor, the evaluators. Assess programmatically your agents using the evaluator. We just launched that 2 days ago. So set up the evaluation in order to understand your overall structure and following for your agents, and you have all of that in the single pane of glass. Last but not least, I wanted to give a couple of resource QR codes here that is useful. The first one, it is demos, demo codes. We have demos in the GitHub available not just on Bedrock Agent Core, but also agents hosted in EKS, ECS, EC2 too. The QR code in the middle has all the links related to AWS observability. So we host a show in a YouTube channel called a Call Operation Show that we talk about observability, call operation as a whole. We have a workshop, best practice, everything that I mentioned, it is in that single QR code in the middle. The last but not the least, the third one, it is a blog post of this particular launch that I just mentioned related to generative AI observability. If you're interested in this topic, I wanted to invite you. We have a lot of kiosks on CloudOps in the village, in the AWS village, and just swing by. We have one-on-one demos. We have SMEs across the globe. So if you're interested to ask a question, myself and Peter is going to be there outside. We also can answer your question. But if you wanted to go to the kiosk, please do so. We have swags, we have stickers, we can do demos. So just go there, and we're going to help you. Last but not least, I wanted to thank you. Thank you for your time. Appreciate it. You come to this presentation. I really wanted to ask you to please complete the survey. We use that data every year to improve our sessions. So if you go to your AWS Events app in your cell phone, you'll be able to go to more and then surveys on the top. This is COP326. So please give your data points related to this session so we can improve next year. So with that, I wish the best of luck to the rest of the reInvent, and thank you very much for being here. Thank you.